Alright guys, welcome to week 2 of Advanced Digital, and this will actually be part 1 of the paneling tools examples. And if you look at the week's page here, paneling tools overview, and you click in the modules, you'll see there is an overview page that kind of basically describes what paneling tools is for. It helps generate 2D, 3D cellular patterns and populate them over rectangular grids, right? So this is a sort of nice beginning point to kind of understand surfaces, surface topology, and how one begins to work with surfaces, especially in terms of subdividing them, right? There are a couple links, one of which is the Food for Rhino download link to paneling tools. And I've also included the installation file, obviously, for paneling tools. This is the latest, most up-to-date version, December 17th of 14. It might, but eventually as these get updated, it's always a good idea to actually check back on this Food for Rhino page just to see if there have been any updates in the time being. All right. Installation instructions are here. As you see, you will need the latest Rhino 5 SR9. Also tells you how to get some toolbars if they don't load automatically, etc., etc. Right? And a lot of these primers, tutorial videos that you can look at. Some of these documents, like the primer, I've also linked here as well. So this is the paneling tools manual. This is more of a mathematics-based sort of description about what's happening. And so you don't have to worry about these right away, but these are actually things that, especially here, the reference material is going to be a little bit more stuff I might talk about more in lecture, or you can refer back to eventually when you're sort of interested. All right? So let's get started. This file will be called PtExample01 begin. Alright, so this will be provided to you. This is an empty file. You'll eventually build this up, and at that point it should look a little bit more like this, right? Once all the options, if you kind of filled everything up, then it'll end up more like this, right? Just so you know. So at the start, I think you should have something that looks like this. You basically have a couple of ellipses, and I have all of these locked, so you don't have to worry about dragging them or selecting them accidentally, right? So these are ellipses, and what we're wanting to do is to loft them. So let's just try them right here. So I'm going to use the loft command. Now remember what happens with the loft command, especially with these. If they are not aligned, well, the result that you get is something like this, right? A very crazy, and if I explode it, very fragmented polysurface, right? Which is not what we want at all for something that is going to rely on surface subdivision, because in this case you would have like 20 different surfaces to deal with, all with different widths, addresses, etc., right? So that's not desirable at all. So when you're lofting this, you have to make sure that you adjust these seam points. Now the seam points should be at the end of the ellipse by default, right? So if I move it around, it should snap to the end. And what you need to do is just to kind of go around these step by step, and just drag these so they are snapping to an end point, just like mine. So I'm dragging it to the end point and looking for. And yeah, there. Right. And sometimes it might take a little bit of getting used to, right? But you're just trying to make sure that these are all connecting to the endpoint, so the rotation makes sense. And these are the arrows, the white arrows, direction arrows, are facing the right direction, right? So once that's done, then you can enter. You can preview, right? So this should give us a pretty clean, seamless, lofted surface. All right, so that's one big surface now, right? Okay. So let's copy that over. And some of this stuff is here just as backup, just in case for whatever reason you can't get the same results as I am getting. Okay? All right. So the next step here, as you can see beside the loft, is extract isocurve. So this is one surface. As you can see, the seam is here. You might have something different if in your display options for this whatever view you're in shaded, for example. If you have your isocurves on, then you'll see this. I usually have this off, just so I can get a better sense of what's happening. All right. So extract isocurve, select surface for isocurve extraction. Now you might, depend on what you had earlier, like this sort of direction toggle, you might need to change it, but basically between the U and the V, it either goes horizontal or it goes vertical. So if you click on toggle, then it will toggle back to vertical. The one we want is the vertical one. And what I'm trying to do is I'm trying to kind of follow this sort of edge, right, and snap to this intersection point. So you'll need your int snap on, right? These snaps, end, point, mid, and int, these on for this to work correctly. But this should be the sort of midpoint of the ellipse, right? The waist point of the ellipse. So then I'm going to circle to the other side and find the other one, right, which is up there. Right? So what that's doing is it's pulling the isocurve of the surface out and creating a curve at that point. And this should be more or less the sort of midpoint of this ellipse, the top ellipse. You can do it from the bottom if you want, just the top one is easier to get to at this point. All right? Okay. So let's, what we're going to do is we're going to take this, both of these curves that we created, select them by holding down the shift, and we're going to trim them. Trim. And we're going to trim off half of the surface. So you're left with this half. And copy it over. All right? So it's starting to look like it, right? Okay. So the next step, any of the commands that are prefixed with the PT means it's a paneling tools command. Okay? So when you type PT, then you'll get a lot of, these are all basically paneling tools commands. You'll also find a new menu here, right, which is a paneling tool specific menu. It depends, like just whatever you're sort of more used to. I almost never use this. I just like type in the commands directly, all right? But it's sort of easier or more consistent. Okay, so this first command is PtGrid surface domain number. And so if you just type PT and then start typing the command, all of the similar ones will start popping up, right? So this one, PtGrid surface domain number, is the one we're looking for. Okay. Select surfaces to divide by number, obviously this, right? Enter. Enter to accept. We should just use the defaults, which the UV subdivisions are 10 by 10, that's the default. And make sure you change this group to yes. So once the thing is created, the point grid is created, it'll be grouped together. So enter. So you'll see it creates a point cloud grid that looks like that, right? And these are based off of the surface. Now, remember that because we trimmed this, right? So you'll see that the subdivision still works off of the whole logic that, okay, any trimmed surface in Rhino is still part of a complete surface, right? And so when you subdivide it using a command like this, it will also sort of actually assume that the whole surface is there, not just what you're showing, okay? And that's one of the things you kind of have to understand or realize. Okay, so let's copy this over again. Now the next command is called, and you can delete that as you go, is called PtTrimGrid. And what this does is it will ask you for a paneling points grid, which is the one we just created, this. Enter when done. Select a surface or a poly surface to trim against, and that actually is this surface. And you'll see that I didn't change anything, but the mode I said inside, which means that compared to the earlier one, it basically deletes all of the points that are not within a surface. Okay. Now if I went back and did it again, okay, select the paneling points grid, this, enter when done, select the surface, and in the mode, you'll see that you have inside, outside, or edge. If you pick outside, what it will do is it will leave the first row of points that are on the outer edge, right? And so you'll have these guys that are sort of floating out in space. And this just kind of really depends on like what you're trying to do for. I'll undo that again. So the final version I want is where the mode is on the edge. And when I trim it against the surface, you'll see that what it does is that it basically moves the closest sort of point to the surface edge, right? So most of these are near a surface edge. Now you will see some weird stuff happening here, right? This guy, I think also because it depends on how the curvature ends, sometimes it actually won't do it perfectly well. So this is actually really easy to fix. What you just need to do is to ungroup this points cloud for now, and you can actually just move this into the right position. So move those points and snap them basically to the corner of the surface. Just in case that happens, sometimes it will, most times, unless your curvature is really extreme, it won't. Okay, so now I'll select everything here and use my control key to deselect the surface and group it back again. So this is still, this is still a valid basically points grid. All right, pretty simple. All right, so what we're gonna do is we're gonna just take this that you just created and copy it over to the next sort of set of boxes. Now the boxes that go in this vertical direction are the ones that are basically going to be options off of this. So you'll see what I mean in a little bit. So let's try. The PtPanelGrid is like the most basic generic command. So this guy, and it will ask you for a paneling point grid, which is this. Enter, and then the base surface. Okay, so right now, right away, you'll see that the sort of way the paneling tools logic works is that you sort of pick through your options one by one. Okay, and these are all the options. So you have to pay attention to these options when you're going through. Now, at first, all of these will be no, 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 right? You'll have grouping on, it will give it a name to the group as well, right? But it will be basically the sort of default pattern is a box. Your panel shape is straight and your add edges is yes, okay? So this is the first one, so let's try it. All right, so once you let it finish, then let's just move this out of the way. And that's what you get. This basically is a sort of generated paneling tools edge structure or edge frame, right, that you got from all those points. Right, so you'll see that we're basically going to be cycling through these. And so let's try that again. PtPanelGrid, paneling points, enter surface. And this time we'll turn off the add edges and we'll turn on the add faces border, which is the next one in the sequence, right? Now, note that you can't actually do all these at once. I'm just sort of doing them one by one, so it's sort of easier to understand. Okay, now this one, this group, we can move it out. You look at it and you'll see that it's actually very similar or almost identical to the first one. But if I ungroup it, both of these, just so you can see, once I ungroup it, you'll see that this version is actually, that's why it's called faces border. This version, like all of these are actually closed polylines. So these will actually give you closed polyline outlines and they will sort of double up. Whereas this version, these are just single elements, right? So this will work better if you're looking to actually use the surfaces or use a sort of subdivided exports these outlines for something. This will probably work better if this is just like a structural thing, right? Eventually, like these are all you want these to be single pipes, for example, and you don't want your pipes to double up or go around in a circle, like we saw earlier with the first grasshopper sort of experiment, right? So this is just a single skeleton. There's no doubling up, and it's not linked together. Okay. So this is the difference between these two. Just wanted to point that out. All right. So let's do this again. Point grid, enter surface, and then let's turn the face borders off and let's add faces. Yes. Okay. So this now is basically the planar version, right? Not planar, but the faces version. Some of these are actually, if you look closely at them, these are actually hypars or hyperbolic paraboloids, right? So they're doubly curved. Yeah. And then you'll see the next, because of that, you'll see the next option is flat faces. And the flat faces actually has several options that we'll have to cycle through. So here we go. PtPanel, grid, surface, add flat faces, yes, okay. And then behind the flat faces method, we'll just use the best fit for now. Okay, let's click on that, move it. And we'll just do these all at once, just so we can compare them all together, right? PtPanel, grid, surface, best fit. So these are all your different options, right? PT0, so let's do 0. And I'm gonna probably fast forward this section, but basically I'm cycling through all those options there. Okay, so now we're done with all the options, and let's sort of take a look. So this is called the best fit, and the best fit basically kind of does an average. It tries to fit the surfaces because these are flat faces, right? These are planar, these aren't doubly curved. So it will basically try to fit to the best it can to the surface curvature at that point. So all of these basically are different versions or different, they basically use one of the 4 vertices of each panel. And the curvature, the surface curvature of the original surface at that point, and use that to determine the sort of direction, right? The inflection, the angle of each particular panel. And obviously for each one of these panels, the direction the surface is going at this point, versus that point from the 4 corners of the same panel are going to be different, right? Because they're sort of facing different directions. So that's where the point, let's say the point 0, point 1 comes from. So 0, 1, and then 2, and 3, right? So these are basically all sampling a different vertex on the surface to determine the overall sort of angle and direction of the panels. And so you'll see that they give you different results in terms of how they match up, right? Some points will always meet, but then let's say in this case, that endpoint is always open, right? So that's what it will really do. It will just sort of affect which of the vertices is going to be open or going to be open like this, okay? So that's the general idea. And then tangent to center basically is similar in some ways to the average, but it gives you a different result. All right. The last one we haven't done here is the add mesh. So PtPanelGrid, select grid, select base surface, and then I'm going to turn off the flat faces and turn on add mesh. And the only difference here really, this, and you can kind of see it looks a little bit different based on how Rhino shows meshes, like the shading is different, right? So this is basically mesh, and you might need this or you might want this if you're doing something eventually more related to 3D printing and exporting it as a mesh. Okay? All right. Let's move on to the next command here, and same thing, we'll just copy this over. Okay, so this command is PtPanelGridCustom. So PtPanelGridCustom, this one. So I'll ask you the same thing, I'll ask you for a paneling point grid, enter, base surface or poly surface, so this guy. And then select custom curves and points. You'll see I've drawn here a square with a circle in the center. So just select all of that, enter. And then you'll see this representation of how this is going to get basically deployed across your surface. And if you don't change anything, by default, it should look like this, 0, 0, 1, 1, 10, 10, blah, blah, whatever, right? Okay. So let's just accept it and see what we get. And grab the group, well, actually this group, move it out using the corners. Okay, so see this is the default, gives you a result like this. And you'll see that what originally were circles, right? They get sort of stretched and morphed to kind of fit your panel shapes, and some of them become ellipses or eggs or whatever. Okay, so let's try that again with the next option by changing the grid size to see what happens. So PtPanelGridCustom, select that, enter the select custom curves and points. Okay, at this point, when it's showing you the representation of this, let's just try messing with this. So the length, let's change that to 8. And you'll see that that automatically in the U direction gives you an overlap with 8. So that means this panel will get propagated with some overlap in between the units, right? So this is actually just a visual representation of what will happen. So let's do that. So see that actually will get, a lot of these get overlapped, right? Which becomes a little messy. But if we change the grid size in the other direction, if it's going 12, for example, then you get a gap in between your panels, which sometimes you might want. Okay, that's just kind of showing you some of the options. The last option here is the UV spacing. So let's try that again. And should be pretty used to this by now. Okay, so let's zoom in here. Length width is still 10, okay? But let's try Shift U, changing that to 2, and then Shift V, changing that to 2. So you'll see the representation is essentially, it starts skipping every other in this sort of pattern. And if we continue with it, what you'll get is something that's like this. Okay, so it's basically skipping every other. And sometimes you'll be able to actually match, let's say, if you wanted to do 2 different patterns in the same surface, then you could actually use something like this to kind of force intervals in between different patterns. Right, so you could fill the rest of it with a different pattern. All right, so that's most of the basic command, which is the PtPanelGrid command. All right. Now those were, and we're going to copy this over again, just as usual. Those were basically 2D panelizations, and now we're actually going to move into 3D panelizations. So the first thing here, and the example that you're looking at is here as well. first thing we're going to do is to offset our panel points. So pt offset points. Okay. So select points, enter, and the distance is 1, right? Enter. Select the base surface or poly surface, which should be this. And it should actually sort of by default go in the right direction. And what you'll see is that it basically offsets the points a certain distance. Now, I don't think in the original, so let's take a look. I made it 3. Okay, so maybe we should exaggerate this a little bit. Now, the other reason I have flip here is that, for example, if I select the surface and I flip it, right? So the direction of the surface, if you type the direction command, is going inwards, right? So this is the way to kind of control the surface was facing outwards, or was the direction of the surface was outwards in the first case. So I didn't have to flip it, but this is the command I use just in case it's not, right? For whatever reason. So right now, if I do the pt offset points command and I select this and I change the distance here, let's say to 3, okay? And we can look at some of the other, there are different distances that are based off of, either, you can base it off a point attractor, a curve attractor, random even. So there's a lot of options here. We won't, basically go through all of them one by one, but you can kind of experiment with, right? So for example, if you did Gaussian curvature, then it would base the distance offset based on the curvature at that point on the surface, etc., etc. But let's stick with this for now. And you'll see, actually, let's try that again. Select points, enter, select surface. So this time it went inwards, right? Because I flipped the direction of my surface, and that's why it's going inwards. Okay, but that's not what we want, so let's flip this back and double check by using the direction command. So, okay, the arrows are going outwards from the surface. Okay, and let's do that again. T offset points. Select your points, enter, select base surface, and just sort of double check that, okay, the surfaces are going outwards from where they should be. They're being offset outwards. Okay, that's what we want. And copy this over, both of these. So you have a surface and 2 different point grids, right? This is the outer one, this is the inner one, and that's the base surface. To do the PtPanel 3D command, it will ask you for a first grid, which is the inside one, enter, and then the second one, which is the outer one. And by default, actually did all of them together, so let's undo that. So all of these were toggled on, and we can try to sort through them if we want, but this is the first pattern, the box 3D pattern, right? And let's just turn this off to make it easier to understand, right? So let's run the command again. So pattern box 3D with edges and nothing else, grouping it. First grid inside, second grid outside. Oops. First grid inside, enter. Second grid outside, enter. Okay. So that actually gives you the thickened, basically, wireframe. Same thing, edges. And I'm going to go through and put in all the options, which you should try on your own as well. Okay, so the main difference between the faces and the solids here is the same as the one we saw between the edges and the border, right, between these two, is that the faces, if you ungroup them and you kind of start deleting away from it, you'll see that these are basically single surfaces, although the sort of edges do double up, or the sort of shared boundaries do double up, whereas these are done as chunks or volumes, right? These are all closed volumes by themselves, right? So which may be good for some purposes like 3D printing. So I'm gonna undo that. That's just to kind of show you the difference, why these look very similar, but the way they're constructed is a little bit different. All right, so we're done with this row, and let's look at some of the other options. The other options will have all these same options, so let's just look at the basic geometry for now. Okay, so PtPanel 3D, the first, and let's check, instead of the box, right, let's try the second one, which is the partition, right? And let's do no solids, and let's just do faces. So inside, outside, and that's what you'll get. So this is basically the sort of inner partition structure of that. All right, generate automatically. Next one. Let's do the wedge version. Inside grid, enter. Outside grid, enter. Okay. So this actually is similar, you know, if you look at, compare it to some of these, right? This is basically the triangulated version where everything is flat. All the panels are flat. They're much more easier to fabricate. You don't have any sort of doubly curved surfaces. All right, last two options, PtPanel 3D. Let's change the wedge to pyramid 1. Inside, enter. Outside, enter. Let's move this out. And let's just do the other one as well. Pyramid 2, inside, enter, outside, enter. All right, so these two, they're basically taking that, except they're pulling one of the vertices outwards and creating this sort of shingle effect. And they just use different vertices or a different way of kind of doing that. This actually merges some of the faces and does them as a sort of much larger pyramidal structure. So you can kind of compare and just like look at the differences between these two. Okay, but these will all basically be pyramids. They'll have a flat sort of inside and then an extruded edge in one direction. So this will have basically that as well. Okay, so I'm just sort of walking you through some of the basic options here that are really associated with the basic PtPanel 3D commands. Okay, so the last one we're looking at is here. You'll have to copy this over again as well, just as usual. And we're looking at this. So this is a sort of module that I created, and you can try this. Basically, select everything and patch it. Use the patch command. I think these should actually be the same. So your surface U span and V span should be the same. Let's just put them both at 2020. Okay, so you'll see it will fit your curves into a single surface, right? and say, if I preview it. And you should try to make this as light as you can. So let's do 10 by 10 and see if it, yeah, it's not a huge deal. Yeah. 20 by 20 kind of gives it a bit of rounding. But we're going to be doing a lot of these, so let's just, and you can kind of mess with these parameters a little bit and say, okay. All right, and then I take the top sort of curve and I trim off the top to get basically this. Yeah, that's roughly the right sort of surface complexity. You don't want, when you're doing this, you don't want the surface UV span to be too high. The higher it is, the more detailed it will be, but the heavier the geometry will be, and you might not even be able to run it eventually. So, all right, so you should get one of these. Take that and just do what I did with there. Okay, so PtPanel. Instead of 3D, we do 3D custom. And the same thing, it will ask you for your first bounding grid, which is the inside, enter. The second bounding grid, which is the outside, enter. And then select two bounding surfaces, press enter if there's none, but let's just use that surface. And then select objects, so I'll select that guy, enter. And so it'll show you the same representation we had, you remember earlier with this, right? Except it's just the 3D version of it, right? Because it has depth and height. And it's going in all three dimensions now. So you'll see it's gained what a U, a V, and UV length, width, and even a height as well. Okay? So you'll see like this should automatically grab, you know, the sort of bounding box of your unit. So you don't necessarily really have to change it. All right, give it a second. It's creating the meshes. And actually I should have grouped it, but let's just do that. So what I'm doing is I'm going to the selection set. This is the select last created. So these are all the last created objects, and I'm just moving them out. And group them together. And so you'll get basically a 3D version of that, which is pretty interesting. All right, so those are the basic fundamentals of, you know, the two main basic paneling tool commands. This one, PtPanel3D, and then PtPanelGrid, with their variations, with the custom variations. Okay. As you can see, when we're kind of going through the process, there's actually a lot more parameter variations that you can sort of test out or play around with. But I think that kind of gives you the big general idea. The last two that are sort of on their own in a way, but can be useful from time to time are these two. Okay, so these two commands are sort of on their own, but they're sort of semi-useful. If you kind of look at the paneling tools, these are sort of in the paneling utility sort of categories. And some of these are kind of actually useful little utilities that eventually that you might try out, right? And obviously you'll see there's so many commands that we won't necessarily be able to kind of go through them all one by one. So I'll just show a few. So this is PtFinEdges, and basically it will take a base surface and kind of extrude, let's say, fins from it in one direction. So PtFinEdges, if I kind of go back, this is what your sort of default should kind of look like, right? Distance method fixed, distance should be 1 by default, but I changed it to 3. And I can select, let's say, a few curves and the base surface to do this. And then basically it just sort of extrudes, you know, that, so those curves normal to your surface, right? And will be more helpful probably in a situation like this, right, where you're trying to grow or trying to extrude the structure out of something that's already in place three-dimensionally. So that's kind of interesting. But some of the other options it has, let's say PtFin, let's say adding a notch. So notch width of 0.5, and this sort of depends on your material thickness, right? A notch height of 1.5, which is half of the distance. That's what I basically had put in, right? So, for example, if I do, let's say, these two sides, give it the base surface, and you'll see it automatically creates a notch there, right? If I run it again, and I flip the notch, but using this option, right, leaving everything else the same, and I pick, let's say, these two sides, and run the command, select base surface. So you'll see that now it actually makes something like this, which, let's say, for example, if I'm laser cutting with a certain thickness, then I could possibly, right, I don't know if these settings are exactly correct, but I could possibly get it so these will fit together, right, if these are actually thickened to a certain extent, right? So this is one of the possibilities. There are probably a lot of others, but you can kind of see how a tool like this might help in some situations. That's, something like this is what you're looking for. And you're free to kind of like try out different variations of it. Okay, so the other one here, which I like a lot, PtTabs, and this is actually a very fabrication-oriented one. So PtTabs, oops. All right, select faces to add tabs. Let's change the distance to, let's say, 3. Recess 0.5 is probably fine. Let's try that. And just select this, right? And enter. And you'll see it basically automatically makes the fins. Let's say if it's for a flat cut sort of thing. And that's really, really nice, because then this is basically what you would send out for laser cutting, right? Now, there's this and this. If I copy it out, right? So this inner would be an edge line, and that outer would be a cut line, right? So this would be one color, the outer would be another color. Let's just say edge is blue, and then cut is red. Right, so this is on change object layer, the red layer, and this change object layer is on the blue. And that basically would be your laser cut file, right? So you can see how this is based off of surfaces, right? How great that can help. Now the other thing that's also interesting is let's just take this, I'm gonna mirror it a couple times, and then join this. Okay, so that's a poly surface here, right? Let's try this command, PtTabs. Make the recess 1, let's see. Okay. And you'll see that it actually works on poly surfaces as well, right? Which is awesome. Now, granted, you'll get a situation like this, right? So this is where you might actually have to kind of mess with the recess amount to get it not to overlap, right? And that's it. Obviously you'll have to extract the inner curves, right? So this is the outside, and that would be a cut. Change object layer. And the inside, so I use duplicate face border, 1, 2, 3, and those are on the edge. So change object layer, right? So you'll see basically this. Whoops. And that actually, when you're looking at something that's more like polysurface based, or that you want to kind of reconstruct like as a cube or whatever have you, something like this can actually be, a command like this can actually be really, really useful for fabrication, right? This only works for, really thin paper, right? Like watercolor, Bristol, that kind of thing that has no thickness really. If it has thickness, then you'll have to use something that's more similar to this in some regards. Okay, All right, that's it for the first file, which is kind of like the most longest and cumbersome one. But move on to the next one.